So first, we're going to talk about process and change management. And a lot of this we've kind of gone over the last week. We did the process last week about how to make s'mores and how to do ramen noodles. And plain and simple, a process is a set of system of activities that use resources to turn inputs into outputs. So we talked about this last time that there are inputs and there are outputs. So whatever gets transformed is in the process. So there's an input that gets transformed into an output. And with that is the system of activities, these actions that we do. And the problem is, or the good thing is, that when it comes to a process, we have resources as well. Now, resources are not the same thing as inputs. Resources are different from inputs because the input gets transformed. It goes with the product as it's transformed. But the resources do not get transformed. They are used to help create the output and can be reused. That's probably the biggest difference, is that the resource can be reused. So for example, if we're making a cheeseburger, our grill or our fire, our flame, our spatula, whatever, these are resources because they're not being made into the final product. The spatula doesn't go with the burger, right? Instead, the spatula is used to help make the burger. And so that's a resource. A person is a resource because they are obviously not going with the burger to the final customer. But they can continue to make more burgers if needed. And so the resources that we have help to transform the inputs into the outputs, but they can be reused and they do not go with the final product. So process thinking looks at activities and organization as a collection of processes. And the goal of supply chain is to reduce costs. So how do we reduce cost? By looking at the processes. Bring more people into the room. So we're going to try to reduce our processes as much as, reduce our processes, reduce our costs as much as possible. And one way of doing this is mapping out the process. So we can map out the process for whatever it is. So for making s'mores, we can map out the process for making ramen noodles. We can map out the process for changing a tire, for doing a fundraiser, whatever project it might be. When you map out a process, you take each individual action or each individual step in the process and you transform it into one of these symbols. So for example, and some of these symbols change depending on the textbook. So I'm just going to use the ones that are on the screen. But anytime there's an operation or an action that has to be done, you can put a circle down for that. So for example, if you're going to offer somebody popcorn at the movie theater, I think that was the discussion forum question, getting the popcorn bucket is an action. That's something that needs to be done. Filling the bucket with popcorn is an action. Handing the bucket to the customer is an action. So for all of those actions, you would put down circles and then tie them together with arrows. Transportation is physically moving something from place to place. So if you're going to move the bucket from the popcorn popping area over to the customer, it's a physical move. Inspection, in this case, is a square. It verifies the results of an activity. So somebody's actually watching to make sure that everything's okay. For example, if you have to put 2 tablespoons of melted butter on the popcorn, then you observe that. Was it 2 tablespoons? Was it 3 tablespoons? Will it be too buttery? Was it 1 tablespoon? It's not buttery enough. So that inspection is physically seeing something. A delay is an unintentional stop for the flow of an input. A delay is when we actually have a step in the process, something's waiting. So for example, in our s'mores example, it takes us about 3 minutes to cook a marshmallow. Well, what happens to the graham cracker and the chocolate that are now together while we're waiting for the marshmallow? Well, they delay. They do nothing. They just sit there. And then when the marshmallow is cooked, then we take all 3 of them and put them together. That's an action. There's a circle. And then finally, storage is when we don't need something. We take something and we put it away. So a formal inventory of inputs. So the extra box of graham crackers we don't need, we're going to put that in storage. Now, how do you reduce and how do you make reduce costs on a process? Look for the delays. Look for the letter D's that are on there, or the half circles. Those delays will tell us, oh, here's a problem. Time is money. It's cost. How do we get rid of these delays? So that's kind of the big thing when you're mapping a process out. And I think here's an example. Yeah. So whatever this process is, notice where the delays are, the half circles. So those delays are where we need to go forward and eliminate those delays. Why are there delays there to begin with? Can we do something else in the process? Do we have to do, if there's a delay, do we have to change those inputs on that part of the process at that point? Or can we wait and do it later? And so all of this is process activities. Notice the triangles are storage. So I mean the storage, I don't need this anymore. Take something out of storage, I put it back in storage, etc. So that could be getting the graham cracker out of the box and the box goes back in storage. Inspection, do I have everything? Does the marshmallow and the graham cracker and the chocolate look good? There's your square. So they look like they're okay. Do I have enough chocolate? Do I have enough graham cracker? Is the marshmallow gooey enough? And then the circle, sandwich them together, put them in storage, or give them to the final customer, whatever it is. So process mapping is one way of doing this. All right, and you can see all the words popping up on the screen. This is one way to do it. So capacity is slightly different. Capacity is the amount of input that can go into or the amount of output that can be created by a process. So given resources. So there are inputs going in the process, they're coming out of an output, and capacity is how many can I do in a certain time period. So in an hour, in 15 minutes, in a month, in a week, etc. And capacity constrains the entire system of activities. So it constrains the entire process. If the process is only as good as the least amount of capacity it has. Let me say that again. The process is only as good as the least amount of capacity one step of the process has. And I'll demonstrate that in just a moment. Two definitions, flow time and cycle time. Cycle time is how long it takes to do one step of the process. And then flow time is how long it takes for one item to go through the process. So all the cycle times added up become the flow time. So we have all of those flows. If you can reduce the cycle time, you reduce the flow time, because again, they're added up to make one step of the process. And capacity, the more capacity there is, the more items that can go through the process, which means the lower flow time overall. So we'll talk about the theory of constraints. Every process has a constraint. Every process has a variance that consumes capacity. Probably no surprise there. Every process has to be managed by a system. So we're observing and watching, mapping our processes. Process measures are crucial to the process success. How do you know you're doing well? If you can get a specific time, a cycle time or a flow time, and you can beat that time, then that's a hard number you know you can beat. And every process must continually improve. And remember this last line. So in supply chains, in literature, every process is based on this theory of constraints, that we are constrained by how we are doing something, making s'mores, right? How do we go about doing this? And everything requires a certain cycle time. Altogether, those add up to be one flow time for one s'mores. And we want to continuously improve so we can reduce our cost. Probably better to show you an example. So if you can imagine taking a bottle, a 2-liter bottle, I've got a small water bottle here. It's the same concept, just imagine a 2-liter bottle. It's a soda bottle instead. And imagine that it was filled with water. If I take that water and I turn it upside down, right, what's going to happen is the water is going to pour out of the bottle because of gravity, and air is going to chug back in because there's only one hole, and the bottleneck, a literal bottleneck, is at the base of this bottle, so by the hole. And air and water have to rush through at the same time. So water will come out, air will chug up. Water will come out, air will chug up. And you kind of have this chugging motion. To drain a 2-liter bottle of water, it's going to be about 9 seconds. And I said I would put this video that I found on YouTube up on Moodle. Just haven't done it yet. Now, another way of doing this, if I want to get the water out of the bottle faster, is I can take the water and I can swirl it around. And so if I swirl it around, it'll create a vortex. That vortex is a drain that comes through, and the water is dedicated to go through. Now, still, it's going to chug a little bit. But because of the vortex, the water is going to pour out the middle, and the air will go up around the sides and then go into the bottle. So it'll reduce the time by about 2 seconds. So about 6 to 7 seconds to get it all out if you just use the vortex method. A third way is if I take the bottle and I put a straw in it. And as I turn the bottle upside down, let's say I have a bent straw, I blow air into it and then let go. And as the air is going into the bottle through the straw, that is a dedicated pathway. So the water can go outside the straw and around the straw and come out. So water has a dedicated pathway, air has a dedicated pathway in, water has dedicated pathways out, which means it drains in about 4 seconds. The point of this exercise is that there are 2 ways to improve a process. The first is to add additional resources. So if I want to increase my capacity, I'm going to add more bottles, more people, more whatever, more air, more water. And so I can get more people to do the job simultaneously. So I can add resources, or maybe add some sort of new, like having the straw, or adding more resources, adding more people in this example. Another way to do it is add technology, innovation. So when I add improved technology or innovation like the straw, instead of just turning the bottle upside down and draining the water, now with the straw as a new technology, it's a faster process because I have dedicated air and waterways. So when you you solve the constraint or solve the bottleneck, what happens is one of two things. You either increase the resources or you increase the technology. Something is called Six Sigma. We'll talk about that a little bit. Continuous improvement. There's a Japanese word Kaizen that we're going to talk about in just a moment. And then all of this ties into something called lean or being lean systems, which again, we'll talk about later in the semester. So here's putting all this together. Here's my sheep shearing example. If you weren't in class on Wednesday, now you get to see it, okay? So imagine we have 4 steps in shearing a sheep. And I came up with this idea when I was watching Dirty Jobs with Mike Rowe, because that episode he was shearing, I think, alpaca. So let's say we're shearing sheep. The fastest flow time for shearing a sheep is 35 seconds. It was an award won by a man in New Zealand in 2016. And there's a whole process for doing that. Well, shearing the sheep is going to be 4 steps. The first step is tagging the sheep and collecting them, putting tags in their ears, knowing which ones need to be sheared on a given day because their wool, their fur is good to go. It's good to be sheared. It's a good consistency. B is giving the sheep a baby Dramamine so they don't get sick, they don't get run away, they're just kind of chill, they're a lot better about being sheared. C is actually shearing the sheep. And then D is getting all the wool. There's good wool and there's rough wool and soft wool. Soft wool or light wool is usually used for clothing, where the darker wool is usually used for mittens or for outer clothing, jackets, etc. So you need to separate the wool. So let's say our capacities in all of these are 400 sheep, 250 sheep, 300 sheep, and 450 sheep. Like I said earlier, a process is only as good as its lowest capacity. And so in this case, how many sheep can we shear through all 4 steps of the process in a day? The answer is 250, step B. So if step A, I can tag 400 sheep, but only 250 of those are going to be given Dramamine. 300 can do the whole shearing step, but again, only 250 are going to get Dramamine. I'm only going to give shear sheep that have had the drug. And so only 250 will be done. And then if only 250 sheep are sheared, then only 250 bags of wool will be collected. So the process is limited by that bottleneck, that constraint that's at step B. So how do I improve the bottleneck? Well, I just said I either add more people, right? Or I have a different drug that I can use that's much smaller, faster time or whatever. So I can have more sheep be drugged so they can be prepped for shearing. So let's change the process and we'll have it at 320 sheep. Right, so let's add a new technology, a new drug. Now, because it's faster acting, I can drug more sheep to be ready to be sheared. So now the process is limited by a constraint at step C, because now that B is 320, C is 300. So now I can only shear 300 sheep, even though I can drug 320 sheep. There are 20 sheep that aren't going to get sheared. So what do I do next? Well, I improve the bottleneck. So for example, let's say at step C, I get another person with a pair of shears. We can do 2 tables simultaneously at shearing. And let's say we can increase that number to 500, for example. Well, now the bottleneck has moved again. So if C is 500, now we're back to B at 320. And so we constantly keep moving the bottleneck depending on the technology, the process, that constraint. What happens if they're all the same capacity? Well, if they're all the same capacity, then they're exactly the same. And that means that any step of the process is good. Any step of the process is fine. I mean, it's a constraint. So we can change any step of the process and continuously improve. So we're always looking at finding that constraint, and it constantly moves every time we add a resource or a new technology. So we have, I mentioned this already, we have inputs, outputs, and resources, and there's variability in those, and we're trying to find a way to reduce the variability, get the same s'mores, the same quality ramen noodles every time, so the process doesn't deviate. And how do we do it cost effectively? There's metrics. Metrics are how we do our measures. It's probably no surprise, but we're in process management. We're going to always measure how long something is, or how long it takes to do something. What is the flow time? What is the cycle time? Or what's our capacity? You're always going to have numbers tied to these actions. Then finally, it brings us to a term, Kaizen. It's a Japanese term. You will see this when you go on internships in manufacturing locations. Kaizen is focused incremental improvement efforts, or in other words, continuous improvement. It's a Japanese term from the 1980s. when Toyota was starting to really focus on improving quality one step at a time. So Kaizen is this focused incremental improvement. We're going to make it better, make it better, make it better, make it better. And all these small improvements will have a large effect, which is why in the 90s, people bought Hondas and Toyotas because they lasted longer. Personal story, I had a Honda Civic that was from 1998, and I think I finally retired it at 327,000 miles. So that quality was there because of Kaizen, this idea that we're going to always make continuous improvement. And quality, as you see in the next chapter, is free. There is no cost for quality. So we're always going to find a way to improve the process of this term Kaizen. So how do you map the process? How do you do this? First thing you should do is look at outcomes. What is my goal? What's my reduced cost? Let's say it takes 9 seconds to drain this bottle of water. Now let's do it in the future with 4 seconds. That's our goal. Reduce our time, reduce lead time. We'll talk about it later. Reduce cost, improve our quality, and then called bounding the critical process. And that is, what is the process altogether? So one small increment of the process. So in other words, if I'm going to hand out food at the concession stand at movie theater, what are the steps in that process? That steps in the process are the customer approaching and coming up to the counter, placing an order. We're fulfilling that order. We're getting what they need, nachos or drinks or whatever, and then finally giving them that, and then we take the money. That is my process. When when a customer comes into the movie theater and they hand in their ticket, that is not part of the same process. That's a different process. So bounding the process is identifying exactly what is the process you're trying to measure. The current state is the as is. So we talked about on Wednesday, there are 4 steps of the process. I'll get to that in just a little bit. So where do you start the process? You start at the as is. So the process as it is right now, not as it's written, not as people think it should be, not as it should be, in your opinion, but as it is right now. Because there are certain benefits and negatives that are going on right now that people don't see, but that's what they're doing. So we always start with the current state, which is as is. Then we analyze, and we can do 4 things. Every step of the process, we can map it like we demonstrated before, or we can do this. We can do what's an analysis of, here's my process. Every step is one of 4 things. Value adding, so it's adding value to the customer, or not value adding, but necessary, something I have to do, or waste generating, something I can get rid of because it doesn't benefit the customer or me, or the question mark, I'm not sure, but let's test it. Let's keep it there for a little bit and see what happens. Okay, when you do the quiz, this is one of the questions on the quiz. The action that's being questioned, is it value adding, necessary but not adding value, waste generating, or question mark? Right? So this is another way to look at it. Every step of the process has one of these 4 characteristics. If we were making cupcakes, what are the different steps for making cupcakes? Which ones are waste generating? Which ones are necessary but not adding value? Hopefully everything is adding value. So here's another way to look at it. And then we're creating a future state map. So we had the current state. Now with some improvements, we're going to look at the future state. How are we going to change things? What's going to happen? Do we need the resources? What's required? And then finally, I'm going to monitor it. We're going to process it, continue to monitor it, continue to make it grow, etc. Now, there are 4 types of processes. Like I said, there's the process that exists. That's what we're going to start with. Then there's the process that should exist in your mind. There's that opinion, and some people get thrown when they try to do process improvement because they look at the process as it should be, not actually exists. Then there's a process as other people working in the process think it exists, and they have their opinions. Here's what we should do. Here's how things do plan. Here's how some of the problems we have. Here's how they should happen. Here's how they should be solved. And then there's the process as it's written, which could be old. Typically, in a class without coronavirus, I have you do a paper airplane game where you throw and make paper airplanes. And I give you work instructions, a listing of the process on how to make a paper airplane. And what happens is you certainly find in the near future that your process, and you change things on your own. I don't want to have this way. I want to have it this way. I don't want to make this fold. I'll make this fold instead. This one seems to fly, etc. And you have all these different steps in the process. And if you were to write those down, you could look at the process that I gave you and the process that you would come up with. And they're very 2 different things. In other words, the process as it's documented may not be good. Instead, it may not be current. It should be the process as it exists now. That's what you should be documenting. So that's why when you look at all these, you should be looking at the process as it exists right now. Now, I went through that pretty fast, but again, it was kind of a recap of what I went over last time. Any questions, any thoughts, any comments? Okay. I'm going to make my way and move over. Let's see here. Let me get the next document out. They're going to do quality. This is more humorous than anything else. Let me share this document. All right. So the first thing about quality is that we recognize quality. We know quality really well. We recognize bad quality better than we recognize good quality. And it's hard to determine what's good quality versus bad quality. Excuse me. So I put some pictures up here of bad quality. So hopefully you guys and some other students can see this in the future of what bad quality looks like. So first off, if you wait at a restaurant for 30 minutes or more, usually you want to leave. And as these people did, is they wrote out their message in ketchup on the table. So you know bad quality. This is a picture from a valet parking activity in, I think it was in Naples, Italy. So probably not the way that you want to have valet parking. We've seen restaurants with bad food that's questionable. I'm not sure whether I want to eat that or not. It kind of looks good, but I don't know, etc. So we kind of can recognize bad quality. And then here's my favorite, the joke or meme that was around, 10 years ago now. This vent here, if you turn it down, it means the air will come through. If the vent is up, that means the air will not go through the vent. The joke is that it's also the symbols for email and bacon. So if you don't know what the vent symbol should look like, that, if you turn it up, you'll get email. If you turn it down, you'll get bacon or water or something. So again, maybe not the best symbols. Here for guys have the man rule. You don't stand within 6 feet of people when you are in the urinal in the restroom. So that's probably a quality fail. For women, if you have to get up and go get the toilet paper because it's on the other side of the stall, this is a challenge, right? So here's a quality fail. If you can compensate, maybe this is the wrong direction to go. Not only is it close, but now I have lots of toilet paper to choose from. So here's a quality fail. You joke about the height or the angle of the houses to the sidewalk. Imagine one of your relatives is in a wheelchair. Probably not the best house to live in. Okay, so when you go out of the house, you kind of go down the hill. Here's another wheelchair example, missing the middle. Here's another, it's hard to see, but this wheelchair example, this ramp snakes about 6 times before it finally gets to the house. So it's just maybe a little bit of overkill for the ramp. Here's another one. I come from New Jersey. So in New Jersey, we have some crazy signage and everybody's driving at 65 miles an hour. So it's hard to stop and see where I'm going. Where am I going? If you see this really quickly, do you know? Here's another one. Why would you bother put the sign up if there's not in use? So what's the point, right? This is another one, which is near where I live. This is in Garfield, New Jersey. And so if you're driving really fast, which road do you need to go in? Where's the 601? Right. Some signs make you question, other signs just make you smile and laugh. So you kind of have the idea what's there. But again, kind of good quality versus bad quality. What's going on here? Where should I go? If I have to make a split-second decision, can I do that? Sometimes it's hard to do that, right? And I've had others too, which I don't have in this slide, that here's a crossed out symbol or an X and then an arrow going right on a path divided. So does that mean don't go right, or the left don't go, but you should go right? So all these are just quality issues. Is it good quality or bad quality? So product quality is how fit is the product for the customer? Does it meet the customer's needs and desires? Similarly, I'm going to use the same term, design quality. So does it meet the customer's needs and requirements? Okay, so product quality equals design quality, no difference between the two. Conformance quality is from the supplier. If I have a design where it's a product like a phone is going to meet the customer's demands and meet their needs, right? So if that's happening right now, conformance quality is trying to figure out, does it meet the design? So does the produced manufactured component, this phone, meet the design recommendations that were created? If it doesn't meet conformance. And so from a customer perspective, a product that doesn't meet your demands or your needs is a design or product quality issue. But conformance quality means that it doesn't meet the supplier's perspective, right? The product isn't designed the way that it should. So here are other dimensions for quality. Again, there's the product quality, performance quality, same thing. There's how well does it meet the needs of the customer. Perceived quality, that's a different one, right? It's hard to measure quality from one thing to another, right? Reliability, does it work repeatedly? Does this phone dial out and call every time I want it to? Or does it eventually stop working? Now, for those people that have purchased products in the dollar store, sometimes we have an expectation, well, I got 5 uses out of it before it died. Then it's okay. So there's that value, that benefit divided by cost. Reliability is how often does it work when I want it to. Aesthetics is how pretty is it? Is it sleek? And I think an iPhone really is. Right here is it easy to use? You can see the icons; they're on there pretty quickly, pretty easily, and I can tap on them. I can see what messages I have, etc. All that is the aesthetics. A Keurig coffee machine looks sleek on the countertop. Maybe a stand mixer looks nice colored, has great breast cancer awareness color, or like a teal color or something. We buy things based on aesthetics. Oh, I think that would look great. Think clothing. You definitely buy clothing based on aesthetics and comfort, right? So we judge quality on aesthetics. Uh, Durability, which is in the bottom row. I used to have a deal when I would go to the classroom. I used to have a Motorola Razor. You guys remember what that phone was? I used to take that phone and smash it against the wall, throw it, and it would break into 3 pieces. And then I could just put it back together again and it would still work. It would have signal. That's durability. So it's not the repeated use of it, that's reliability. Durability is if I break it, does it still work? How much beating can it take before it finally breaks? Features, what are the neat features of it? Something that gives me quality and a hope for quality. Then it's conformance quality that we talked about, and then finally support, post-purchase support. Have you ever called Comcast or AT&T after you've used their service? Usually the support leaves much to be desired. It's not a great support system. Apple, however, Amazon, they have great post-purchase support. So they get back to you, they'll help you with your problem, etc. So sometimes we buy products based on the support that I'll get. I don't really know what I should buy, but I know X company has really good post-purchase support. I know I'll feel like I'm in good hands with those people. Insurance works this way. So you buy insurance based on a price, and then if you have to make a claim because you were in a vehicle accident, how easy are they to work with? How high does your insurance premium go after the accident? That's support. So sometimes we buy and we say, hey, some companies have great quality. Last question I'm going to go over before we stop is what department is responsible for quality? And the secret answer is all of them: procurement, logistics, operations, HR, PR, finance and accounting, engineering, marketing and sales. Everyone's responsible for quality. How do you improve the process? How do you improve the customer experience? So all of these aspects, all of these different departments are responsible for working together to improve the customer experience, to improve quality. So whatever the company, if it's a product you're selling or a service, what helps people say that company has good quality? Why does Chick-fil-A have good quality? Is it the food? Well, the food's pretty good. The wait time when I'm in the drive-through, they're always improving that. So I have great quality there. The customer experience, if I say thank you, they say my pleasure. The way that they actually will talk to you and make you feel like you're the important customer, excuse me, at the moment, that's good quality. All of the different departments are involved in good quality. And so it's not just one quality department, even though that is a department for a product or for a project. It's everyone in the department. So that's all I've got right now. I will stop right here because it is, well, it's 8:34. You know what? I'll continue just a little bit more and then I'll stop. But give me like another 5 minutes. Service quality is another one. So there's a difference between product quality and service quality. I don't have this written on the slide, but I think I'll mention it. I'm gonna go back here. So here's quality for goods and services. All these are true, but there's a couple more for service that are really, it's worth mentioning. I'll mention two. There are actually four, but one is intangibility. It's hard to measure a service because of its intangibility. Now, the service may have physical goods or resources, let's say a laundromat, right? So there's a quality of how clean my clothes are when I go to the laundromat. And the question is, my laundromat experience, is that good? Is that a good experience? I have certain machines I use. I have certain baskets that I use. The cleanliness of the store is good. That's tangible. But a service is often intangible. I can't physically touch it, so I can't measure it very easily. So all those things are intangibles. That's hard. And second, worth mentioning is inseparability. In a service, if I say I go to a restaurant, there are so many ways as to why I can be turned off. I can be upset about something. The food is tangible, right? That's the goods part of the restaurant. But it could be the waiter, it could be the bathrooms, it could be the cleanliness of the room, it could be the tables, it could be whatever, right? There are so many reasons as to why I could have a bad service experience. But putting your finger on it is hard because of the inseparability. If you go to the drive-through, was it the service of the person that was there, or is it the culture of the organization? Think Taco Bell, right? I had a bad experience. Why? It's hard to separate the person from the culture, from the food, from the maybe the person behind me was honking at me in drive-through and they're pushing me to go forward because they're really hungry or they really want me to go. Like that bothered me. It wasn't the service. It wasn't the person handing me the food, or maybe the card reader didn't work. So there's a product, but it's hard to separate why something in a service didn't go well. It usually is a combination of different things. And so it's worth mentioning a service is hard because of intangibility and inseparability. Okay, now I'll stop. So I'll let you guys go. Thank you for joining me today. I'm going to stop share right now, and then I'm going to stop the recording.